Okay, today we're going to be working on conditional distributions and then how to see an association once we break down conditional distributions. Okay, so we're going to start on page 14 in your textbooks. And just like the Q, well, I guess you don't have a Q in your notes, but I wrote it in here. But I want you guys to start off by reading page 14 through 16 to yourselves. Once you get to the conditional distribution, don't jump ahead. Read for understanding first, please. Like I said, these authors are good. They know how to explain things pretty good. So read through the conditional distribution explanation and get through this example over here as well. Okay, give you about 5 minutes to do that, and then we'll have a discussion to follow. Okay, so when we're doing conditional distributions, we want to, it's kind of like the relative frequency we talked about yesterday. We had frequency tables, which were counts, and then relative frequency tables, which were converted to percents. All right, so it's not always wise to just use counts. For example, if I take a look at this opinion, almost no chance of getting rich, males have a higher count. So they must be more likely to respond to that, right? No, look at the totals. There's more males in this sample than there were females. Okay, so then if we break it down by percentage, males would be higher. So almost no chance. If we look over here, this was the male column, and they went 98ths out of the total males. Okay, broke it up by gender now, that condition. So they were at 4%. Well, what about females? If I flip the page, females were 4.1. So actually they were slightly higher in that response when you put it in perspective. So don't be fooled by the counts. You shouldn't compare those. We should compare the percentage. Okay, and the denominator, it should make sense to use males because, 2459 for the total amount of males, and then 2367 was the total amount of females. Okay, and why do we break it down by condition? So then we can make good comparisons of what's high and what's low. Okay, and then also in the reading you saw, make a graph to display the conditional distribution. Use a side-by-side bar graph. I highly recommend that. Or the segmented bar graph. These get a little more complicated to create, but they're easy to read. Let me show you a segmented bar graph, okay? It's right here on page 17 in the book. They took these percentages. Let's look at the side-by-side bar graph first. And it's very easy to make comparisons. They made a little key. The red is the male and the blue is the female. And you can quickly look and make some comments about the association, right? Which was higher, which was lower. Right here, there's a big gap. Females tended to choose the response of some chance more than males. Okay. Where were the males a little higher? These two categories. Males were higher and almost certain or a good chance. So they kind of had a little more optimistic view of their future, I guess. So when they ask you to describe what you see, you should talk about those differences. Okay, and they're pretty close on these two categories. All right, so 3 sentences would be plenty. All right, and so we can see what they did too on their response when you read through this example here in just a moment. All right, here's the segmented bar graph, though, I wanted to show you. It's a lot like a pie chart. It breaks it in percentages. Look, it's from 0 to 100, right? So the male and female blue, almost none. They were both around 4%. Okay, so they just tried to estimate 0 to 4, right? So that's a segmented bar graph. It takes a long time to do a good one. I don't recommend it, but it's like a pie chart. Breaks it down to percents. Okay. Okay. So compare the differences of conditional distributions and notice the differences in data on pages 16 through 17. I'm talking about the notes right here. All right, so let's go ahead and fill this in if you haven't already. We can do it together. All right, my first comment here is men seem a little more optimistic about their future income than women. Okay, remember I kind of already talked about that. It was because of the some chance, right? The females were quite a bit higher in percentages. So men seem a little more optimistic about their future income than women. You can maybe skip this part. I just got a little more detail. They were more likely to choose, almost none, and some chance as a response. Let's move ahead to this other one. While men were more likely to choose the title good chance and almost certain as a response. You see that good enough? I can't see it. So this leads us right into an association. All right. Knowing that somebody is a male or female, just say male, going into this, I might be able to make a prediction on some choices they might choose because we can see an association between those conditions. All right. So here's the technical definition of just that, association. We say there is an association between two variables if knowing the value of one variable, gender, helps predict the value of the other, their opinion. So we say there's an association between two variables if knowing the value of one variable helps predict the value of the other. Okay, let's try this check your understanding here to wrap up this section. In your book, it's page 18. It's the next thing in your notes, though. So go ahead and read that over. I'll try to push you in the right direction here in just a moment after you've had a chance to read the directions. Go ahead. Okay, so to find the conditional distributions, you're going to want to, I have these totals for you real quick. This is 200. Oh, hold on, my screen's on freeze. There we go. This is going to be 200 right here, and this is 215. So once again, the counts aren't the same, so we don't want to compare counts. We want to compare percents, and this is conditional now. We're using the numbers inside, not just the margins, the numbers inside per condition. All right, so the response, or if you keep it in line, I guess you don't need to write those words down again. I did, but then I made a column right next to it for percent of UK and percent of US. Okay, and then from there, now we can take the percentage of United Kingdom kids that chose flying by doing 54 divided by the 200 that were surveyed. That becomes our conditional response. Okay, so your denominator changes when you start using conditional. Percentage of US, 45 over 215. Change it to a percent. Okay, give you a couple minutes to do that. Then go ahead and make like I said, I don't think the pie chart or segmented bar graph is a good idea. For step 2, I'd do a side-by-side bar graph. I want you to do it this time. This is the first time you've done it. Okay, so here's what our bar graphs look like if they're next to each other. I made UK, the open one, US, shaded in. Obviously, since we don't use all the y-axis, you don't really need to extend it to 100. Okay, so is there an association between country of origin and superpower preference? You're basically asking, do we notice a difference? Can we make any predictions knowing that the kids from UK or US? Or is it just level all the way across and there is no association? Well, they're not level all the way across. Okay, so kind of in your own words, but we should talk about the big differences. So here's what I put. It's compare it to what you had, or just write this down if you didn't do anything. There is an association between country of origin and superpower preference. Okay, so when they say, is there an association? First answer is say yes or no. Yes, we see one. Like I said, if it was level at every category, I would say no. Everything kind of looks, there's no association. Everything looks pretty even on the responses. Students, now I'm getting more specific, students in the UK are more likely to choose flying and freeze time. While the US students are more likely to choose invisibility or telepathy. Super strength was almost even, so that's what I noted at the end. Super strength was about equal in both countries. I even added equally unpopular because it was the lowest. Nobody wants to be Hulk, apparently. I'll take Hulk for a day, that's for sure. Okay. You guys have any questions as a group on that? Okay, so we're done with 1.1. Remember, 1.0 is just categorical versus quantitative. That was it. And what inference means. So it's really just kind of still one section with the intro. We should be ready for a quiz Monday. I think what we'll do, though, is since coming back from the weekend, first quiz, we'll do a little review together before we take it. We won't take it right away. It's going to be a small quiz, mainly multiple choice. We'll probably do it near the end of the hour because I've got some bookwork I want you to do the rest of the hour today and this weekend. And then we'll go over that. And then I got a little handout review that we can do a little more practice together. And then we'll quiz and maybe even start 1.2 after that. Okay. So for the remaining time here, let me get you your bookwork I want you to work on the next 15 minutes here. Okay.